This is a production of Cornell University.
Take a deep breath. You guys made it through. Okay, what we're going to start talking about now is we're going to start talking about management. Okay, and the traditional thing that we talk about with management is we traditionally talk about agriculture. We're going to talk about some other things here, but we traditionally talk about agriculture because agriculture is a huge stochastic event when you start talking about soil organic matter. Okay, so we start at time zero here, and this is basically a transect of time. Okay, and going up, we're basically looking at percentages of organic matter in the soil. Okay, some initial event. The material was just laid down. Over a period of time, organic matter is going to build up. Okay, plants are going to start colonizing, and once they start colonizing, the rest of the organisms are going to start coming in. Okay, and these organisms and the plants are going to die and leave stuff behind, and that stuff will be integrated into the soil. And somewhere down the line, you're going to get to a flat line. That flat line basically represents where accretion and decomposition are equal. Now, another stochastic event occurs. In this case, it's cultivation. Well, what happens with cultivation? Okay, obviously you can see the line, it says this huge drop. But why is there this huge drop? Any thoughts? If we think about what's controlling decomposition, and I guess if we're talking about what's controlling decomposition, we also have to talk about what's controlling accumulation. If we think about those two things and an initiation of a cultivation event, what's happening to drop this?
And if you're plowing, then you're adding a lot of oxygen where there wasn't as much before.
You're changing the environment where decomposition is occurring. Okay? You're changing the location. Okay? And so as a result of this change of location, you're making things more available and decomposition rates potentially increase. Reason number one. Reason number two, and these are probably the two most important ones, if we're looking at this number and one of these numbers has to do with decomposition, the other part of the equation is what happens to accumulation. And if I'm changing my plants and I'm harvesting those plants, remember this is cultivation, I'm taking plants away, there's not as much organic matter that's making it to the soil. Therefore, my rate of inputs are dropped, and I'm also increasing my rate of decomposition. What's going to happen? I'm going to have a huge plunge. Now, sooner or later, we're going to flatline again. Sooner or later, that organic matter and that decomposition rate are going to come to accumulation, or accumulation and decomposition are going to come to equilibrium, or a steady state might be a better way of saying that, and we're going to have this. Does that make sense? Okay, so let's actually talk about what happens here, but I want to show one more thing here, actually two. These are those pools. Here is the start of cultivation right here. Here are the three pools. Okay, here's plant residue. You can see what happens to these pools. All of the pools basically get dried up until there's generally you'd have a flat line here. Now in this scenario we have another stochastic event. In this stochastic event, cultivation stops, and we either put it back into a native vegetation or we improve our organic matter management. Okay, i.e. we go to a no-till system or something like that, and as a result you start seeing an accumulation. Okay, this traditional idea about what happens when you stop cultivation. Okay, but this is a traditional idea that's mostly associated with temperate environments. Here's a different vision. Okay, here, traditional vision. Okay, I'm seeing high organic matter. Okay, agricultural event, drop, cessation of the agricultural event, and an increase. But think about it this way. What happens if this agricultural event was put into an environment which was a desert? How much carbon was in that soil prior to agriculture? Probably not much. Once I start agriculture, though, what's going to start happening? I'm going to start adding water to the system. I'm going to start adding plants to the system. So traditionally, we always think agriculture, drop in carbon stock. But you also have to think about location again. If that location is in a desert, and I start adding plants, I'm actually going to start seeing an increase in the carbon stock. So you really do have to think about where this practice is taking place. Now, in general, and all beneficial environments for agriculture where we're taking advantage of what's going on at that location, in general, we basically see a drop. But there are scenarios where potentially you will see an increase by a stochastic event such as an agriculture event. Now, right here we have another conversion. This is another stochastic event. This is an agricultural conversion here. This is an urban conversion. What happens in an urban environment? This is a sort of a tidbit I like to throw out there, but if you think about diversity, just diversity, outside of the tropical rainforests, the most diverse environments in the world are what? Urban areas. Now, interestingly enough, we're talking about diversity, not abundance. Okay, a big difference there. Okay, but urban transition, what happens? Often we see an increase in carbon stock because of how we manage these environments. Yes, they are highly disturbed, but we are also putting in lots of stuff. Now the question is whether this is carbon stock coming from plants. This could be basically carbon stock coming from demoed buildings for that matter. But we are seeing this increase in carbon stock in the soil. Okay, cool, interesting. And this is all about management. Go. Well, think about an urban environment. Well, think about campus. Think about all of the different types of sort of, this is the wrong use of the term, but how many different ecotypes there are here. I mean, you think about all the exotic plants that we bring in and all the organisms that are here because of those exotic plants, as well as more locally, I mean, the native species. And then take a look at New York City. And you sort of imagine the diversity that's there. I mean, how many of you guys have plants in your rooms? How many of those plants are from central New York? Well, those hands disappeared real quick. I have them too, but and then, okay, on top of that, if I've got a plant from an exotic site, okay, I've got exotic soil potentially with it. Certainly I've got potting soil mix. Okay, what type of microbial and arthropod species are associated with that plant that are not native to this area? And suddenly you start seeing where this diversity comes from. It's not abundance, it's diversity. Okay, cool? All right, so this is all about management. Now, primarily we've been talking about decay, okay, factors that are controlling decay. But how about we talk about factors that control accumulation? They're basically the same thing. I mean, if you think about it, they're basically the same thing. All right.
This has been a production of Cornell University, on the web at cornell.edu.